In any environment where electrostatic discharge, ESD, must be controlled, like electronics manufacturing, semiconductor manufacturing, and cleanrooms, flooring resistance is a key technical factor. Most ESD flooring on the market today falls into two categories: conductive, 1.0 times 10e4 to 1.0 times 10e6 ohms, and dissipative, 1.0 times 10e6 to 1.0 times 10e9 ohms. These ranges are familiar, but that doesn't always mean they're optimal. IEC 61344-9, which is the standard for electrostatic properties of floor materials used for personnel grounding through footwear, defines three resistance zones. Below 1.0 times 10e5 ohms is considered too conductive and may pose a shock risk. Above 1.0 times 10e8 ohms is too resistive and ineffective for ESD. The ideal range, between 1.0 times 10e5 and 1.0 times 10e8 ohms, is optimal for safely dissipating charges while minimizing electrical hazards. According to IEC 61344-9 and technical guidance from major facility standards such as IBM's recommendations, the most practical and safe resistance range for ESD flooring is between 1.0 times 10e5 ohms and 1.0 times 10e8 ohms. This ideal resistance zone strikes a balance between sufficient conductivity to safely dissipate static charges and enough resistance to avoid electrical shock hazards. This sweet spot also provides greater stability in real-world conditions. Environmental factors such as surface dirt or low humidity can raise floor resistance significantly, sometimes by 2 orders of magnitude. In dry environments especially, a floor that initially measures near 1.0 times 10e9 ohms can exceed 1.0 times 10e10 ohms, effectively turning into a static generating insulator. Floors in the 1.0 times 10e5 to 1.0 times 10e8 ohms range are more resilient under these conditions. Even when humidity drops or contaminants accumulate, they typically stay within a functional resistance zone, continuing to protect sensitive components and personnel. Y.H.F's free of carbon fiber ESD vinyl flooring sheets 2100 series are precisely manufactured to deliver stable electrostatic control within the ideal resistance range of 1.0 times 10e5 to 1.0 times 10e8 ohms, ensuring both effective static dissipation and electrical safety. Thanks to advanced carbon-free conductive technology and tightly controlled manufacturing processes, resistance values are highly consistent. Most readings fall in the 1.0 times 10e6 ohm range, fewer in 1.0 times 10e7, occasional at 1.0 times 10e5, and none exceeding 1.0 times 10e8. This stability ensures long-term performance even under challenging conditions such as low humidity or surface contamination, making the 2100 series a reliable and durable solution for manufacturers and areas demanding robust ESD protection.